If f of x is the square root of x and g of x is x squared, find the natural domain and corresponding range of, first of all, g of f of x. So our x values are going into f first, and that's the square root of x. The output from that will go through g, which is the squared function. Only root x has a problem here. We can't input negative numbers into root x. X squared is fine. We can square any number. So we have a problem at the beginning in that we're going into root x. We can put in real values as long as they're greater than or equal to 0. When we square root, if we think about the square root function, the output from that is also real numbers greater than or equal to 0. So that's what's going to end up here. And those can all go into x squared. And if we square real numbers greater than or equal to 0, then what we'll get as output are numbers that are greater than or equal to 0. So our domain is reals greater than or equal to 0. For the range, we can write y, or we could write gf. So gf is a real, gf greater than or equal to 0. If, however, we look at the other way around, f of g of x, that means that we start off with x, and it goes into the squaring function first. And then what comes out of there goes into the square root function. There's no problem with input into x squared. All reals can go in. And if we're squaring, what comes out will be real numbers greater than or equal to 0. So there's no problem going into the second function with any output from x squared. The root x function, as discussed in part A, is going to have output, which is real numbers greater than or equal to 0. So for this one, the domain is all real values, and the range is real values. We could write y here, or we could write fg. But here, those values can only be greater than or equal to 0. You should note that if we put x into this function, what comes out is x squared, and then x squared goes into root x. So what comes out is root x squared. Now you might think that that's just x, but actually that is mod x. Now we're going to talk a lot about modulus functions later, but it's worth remembering that the square root of x squared is mod x. This has been examined several times over the last few years.